Lesson 3 of Chapter 5 is going to talk about rate of change and slope. This is something that we did briefly visit in pre-algebra, but we're going to hit a bit harder this year. So, rate of change is a ratio, which means a fraction, that compares the amount of change in a dependent and an independent variable. The independent variables, by the way, are our x's, and dependent variables are y's. We'll also talk about rise and run. Rise is the difference in y values between 2 points on a line, how far up and down you have to go. Run is the difference in x values between 2 points, how far left and right you have to go. Slope is the ratio of rise to run. So we've got a few formulas here. Rate of change is the change in the dependent variable over change in the independent variable. And slope is rise over run, which is change in the y values over the change in the x values. First example, this table shows the cost of mailing a 1-ounce letter in different years. Find the rate of change in cost for each time interval. Identify the interval with the greatest increase. Okay, so the first thing we got to do is actually identify what the changes are here. So from 1985 to 1988 is plus 3. From 1988 to 1990 is plus 2. From 1990 to 1991 is plus 1. And from 1991 to 2004 is plus 13. As far as the cost goes, 22 to 25 cents is plus 3. 25 to 25 is plus 0. 25 to 29 is plus 4. And 29 to 37 is plus 12. Now, here's the thing that's a little bit weird. These tables, when we've seen them before, would be x's on top and y's on the bottom. Okay, the independent variables on top, dependent variables on the bottom. But rate of change is the change in y over the change in x. So, when we put these together to make our ratios, our fractions, we're actually going to be flipping them. And what I mean by that is, and let me do this. Now this first one, no matter how you try to imagine this, it's going to be a 3 over a 3. Which is 1, and yes, you still have to simplify fractions that simplify. But this next thing has a 0 and a 2. Or a 2 and a 0, however you wish to look at it. When we set up the rate of change, it's got to be the bottom over top for a table. 0 over 2, which is 0. And there was no change there, so that makes sense. This next one is 4 over 1, which is 4. And the last one is 12 over 13, which doesn't simplify. 12 over 13 is 12/13. The interval with the greatest change is right there, because our changes are 1, 0, 4, and 12/13. 4 is the biggest. So that's rate of change. It's change in y, or change in the bottom, over change in x, or change in the top. On a graph, slope is very easy. Simply start at the point on the left and say, okay, to get to the point further to right, I need to go up 3, right 2. And we can only travel in straight up and down, left and right lines. We cannot travel diagonally, because we can't count that right now. So, up 3, right 2 is a slope of 3/2. When we do slope, we will always do up and down, then left or right. On the next example, to get from my left point, 1, 6, to my right point of 1, 2, I have to come down 1, 2, 3, 4, down 4, and down is negative. And then I have to go right 2. Right is positive. So that is negative 4 over 2, and that does simplify to negative 2. Find the slope of the line that passes through 0, negative 3, and 5, negative 5. Okay. So slope is from, and this is from above, the change in the y's over the change in the x's. So we could do this without graphing. The change in the y's. So let's just say that we're changing from this ordered pair to this ordered pair. We're changing from 0, negative 3 to 5, negative 5. To get from negative 3 to negative 5, from the first y value to the second y value, requires going down 2. It's a drop of 2. To get from the first x value to the second x value, 0 to 5, that's an increase of 5, which we would just represent as a positive 5. There's the slope, negative 2/5. That's it. Find the slope of these lines. So there are some points marked here. They're a little difficult to read, but that doesn't matter. Here we go up 0, because we don't go up, and we go right 1, 2, 3, 4, 5. So rise over run. 0 over 5 is 0. And that's fine. 0 is a number. 0 is okay. That's a horizontal line. It's flat left to right. It has a slope of 0. Its counterpart on the right here goes up 4 and right nothing, which means it's 4 divided by 0. That is undefined. You cannot divide by 0. This is a vertical line. Vertical lines have undefined slope. And we've got that right here listed for us. If a line rises from left to right, its slope is positive. And that looks like the graph on the left here. If a slope falls from left to right, it has negative slope. That's my graph here that's blue and yellow. And you can see negative 2 is the slope. Horizontal lines, which is the left graph here, have slope 0. And vertical lines, which is the right graph here, have an undefined slope. That's not 0. That's not no slope. It is specifically undefined. And that is the only correct answer to the question, what is the slope of a vertical line?